Hello everybody, we are going to charge into congruent and similar figures. So buckle up, we'll see how proportionality relates to this geometric skill. So the first idea here is congruent figures. What does that mean? It means we have an exact carbon copy of shapes. All angles, all side lengths would be exactly the same. So you can see A, B, and D, E, same side length. Those are congruent. B, C, E, F, same side length, congruent. And A, C, D, F, same side length, so those are congruent. And even if the shape is turned or flipped, it does not matter. If everything is the same side length, we have congruent figures. Congruent. Congruent. And congruent. So this just shows no matter what you do, turning, flipping, rotating, whatever, sliding things along, this is always going to be congruent no matter what happens. You can always turn it back to its original position to make a congruent figure. All sides and all angles are exactly the same, therefore the shapes are congruent. So here we have congruent figures. We have some missing side lengths here. Very easy to see what those numbers would be. You just got to find corresponding sides. The JK, TS are corresponding sides. IK, RS corresponding sides. And JI, TR corresponding sides. So our missing side lengths, this would be 61. This would be 50, making the congruent figures. So what does it mean for shapes to be similar? Well, all the angles of the shapes would be the same, but the sizing would be different. We're enlarging or shrinking, but the general shape stays intact. It would be proportional no matter what size it is. So here you can see we have similar shapes. No matter how I size it, the angles are going to be the same. I could just overlap and you could see that same angle, and same angle. So these would be similar shapes. The only thing that changes is the sizing, but all the proportionality remains intact. So speaking of proportionality, what do I mean by that? Well, let's take a look at similar figures here and corresponding sides. 10 becomes 20 in the new figure. 7 becomes 14 in the new figure. 6 becomes 12 in the new figure. You can see that there's a constant of proportionality of multiplying everything here by 2 to make the new enlarged figure here. How else can we see proportionality in these figures? Well, if we take the bottom and compare it to the longest side in both of these figures, we have the same ratio. 7 is the bottom, over 10 is the long side for the first figure. On the second figure, 14 is the bottom, and 20 is the longest figure. You can see that these two ratios are exactly the same amounts. Therefore, we have a proportion here, and we have proportionality in our figures. So see if you can find the two missing side lengths in the similar figures here. We're not given much information. The only thing that we know that our corresponding sides AB and EF goes from 4 to 28. All the angles in the shapes are congruent. Therefore, we're going to have an enlarged figure over here. So these are similar. So we have to find the constant of proportionality going from 4 to 28. Do you see what that is? Yep, that's going to be multiplying by 7. So take 5 times 7 and you get 35. Take 6 times 7 and you get 42. There are the two missing side lengths in the new figure. So let's prove how proportionality works again with ratios, but let's do it a little bit differently. Let's take the bottoms, compare bottom with bottom. So 5 over the other bottom, 35. And let's compare those with, I don't know, let's just do the right side, 4 and 28. Both of these fractions are going to be equal to each other because I know that they both equal 1/7. If you reduced simplified to its lowest terms, both mean 1/7, therefore the fractions are equal, therefore it's a proportion, and therefore proportionality exists in your figures. So let's take one more example and see if we can find the missing side length in the smaller figure. So we do have similar figures here. Do you see the constant of proportionality? It is multiplying by 3. Some people call this constant of proportionality a scale factor when we're dealing with similar figures here. So 8 times 3 makes 24. 6 times 3 makes 18, so this number times 3 makes 21. Or you can think about it in reverse. 24 divided by 3 equals 8. 18 divided by 3 equals 6. So 21 divided by 3 would equal 7 here for us. And if you wanted to, you could set up any kind of ratios, prove that you have proportions here, and it would work. So in this last example, you can see that we don't have similar or congruent figures. We do have one angle that is the same, but the other two angles are not equal to each other. The side lengths are different. There is no proportionality in this. There is no constant of proportionality. 8 to 8, that's multiplying by 1. 7 to 14, that's multiplying by 2. And 5 going to 12, that's multiplying by 2.4. That's 3 different numbers. That does not keep the figures similar, so we do not have similar figures here, and they're definitely not congruent either. So time is up. Hopefully you understand all these new skills and it's all good for you.